Alright, welcome to this thinkingParticle tutorial. This is going to cover something that is very common when using the mass operator in thinkingParticles and dynamics. So I wanted to touch base on that and also talk about an air friction setup. So when you're doing dynamics, in this example we're going to be using SC, shape collision, in thinkingParticles. When you're using the mass operator in thinkingParticles and you have the little checkbox sizes mass, a lot of times when people do this, they plug this into their particles and they'll say, yeah, I don't see any difference here. Well, you are if you're using a simulator like SC, because in SC, same thing as in Bullet, you have sizes mass. What that means is when particles are actually colliding, there's a collision happening, mass is taken into account, right? So the size of the object matters. So if you're not doing that with your simulations, you should get in the habit of assigning mass to your objects, your particles, your debris, your fragments, all these things, because it's going to make it behave upon collisions during the simulation much more natural and realistic. So example of that is I have some small boxes, some medium boxes, and some large boxes. Right now sizes mass is turned off. We're using an SC dynamic simulation. None of the particles have any mass assigned to them, so when I play this down we get boxes that fall over. No big deal in this situation. But if I look at the left viewport and we take a look at actually these boxes as they fall, and we just kind of step through it and we can kind of see, this is what's common with people when they look at this. They'll say everything's falling at the same rate, right? So when I plug in the mass operator, I would expect heavier objects to fall faster than the lighter objects and so on, and that doesn't occur. It doesn't occur because, again, the mass operator is designed for during the dynamic simulation on collisions, right? A large object should be able to push that small object. You don't want a small object pushing a large one, right? And so on. So as these fall, these are all falling at the same rate, right? And when they collide, they just kind of fall down. You know, I would expect maybe the bigger objects to push a little bit more on the smaller objects, right? And so on. So what we can do is first start out by saying, okay, the first thing we're going to do is we're going to assign sizes mass, and we're going to plug that into our boxes, right? So now these boxes will get a mass based on their size. The simulator SC will turn on sizes mass and we'll play that down and we'll get a different behavior, right? Again, nothing too drastic or too dynamic here, but when I step through it, we'll see that there's going to be a different behavior because it's taken into account mass, right? So the larger objects are pushing a little bit more on the smaller objects, right? Okay, so once you have that set up, the next thing would be is to add a rule to give you that air friction so that heavier objects fall faster than the smaller objects and so on, so you get some differences when things are airborne and moving. So what I have for that is I have a rule that I use quite often called air friction. In this rule I put it after the dynamic simulation, and what this will do, I'll make this a little larger so you can see it. What this rule says is basically objects in your simulation that are in gravity, right? So if I had a bunch of stuff in this gravity rule, right now I just have fragments, which are the boxes that we're using in this example. Those are having rules applied to them after the dynamics to give them a little bit of friction. So large objects have a little bit of friction, medium objects a little bit more, and smaller objects a little bit more than that. Just so that we have small, medium, and large sort of, and this is general ranges, right? So what I'm doing is I'm saying if you're in the gravity, which means you're an object that's dynamic and moving around, I'm going to look at velocity, and every velocity threshold is identical, right? And the reason for that is basically if you're moving larger than the value of 3, then you're going to get these rules applied to you. So if you're just already sitting on the ground settling, I don't want these rules to be applied, right? There's no real benefit. But if fragments, shrapnel, things like that that are airborne, moving around, all these dynamic things, I want this rule to be applied, okay? And then simply I just have a size threshold that says if your large objects are above this size, you get this value. If you're medium, you're just below the large value to a certain value, and same thing for small, right? So what will happen is when I actually go and turn on this rule, so we have again sizes mass, and a mass operator assigned to our large particles, or not our large particles, but our box particles here. And now what we have is basically an air friction rule here, And that'll make these objects behave a little bit differently when they're moving and they're in motion. And if we look at the left viewport and we kind of step through that, you can really see what's going to happen here as I step through this. So we step, now everything starts to get out of whack as far as their lineup, right? So larger objects are falling further than the smaller ones. You can see that nothing is in a straight line anymore. So before, everything was basically in a straight line because there was really no difference in mass except for on collision, right? But you can see here, these objects are now not in a straight line. The larger objects are falling a little bit faster than the smaller ones. You can see here, this one's almost caught up to this yellow particle here before it actually hit the ground, right? Because that one actually caught up to it because it's heavier, right? So that's a good example right here. As this falls down, you can see clearly before it hits the ground, it's catching up to this particle here. And when I have that rule turned off, if we turn that off, forward and back a frame, we can step through here and there's no change all the way down, right? This particle at the top that's large doesn't get close at all to that yellow particle because it's just falling at the same rate. So to get a more realistic behavior, you set up a rule like this for air friction. It just gives small values. You don't need a lot of large values because then things will start looking like they're floating or swimming or underwater, things like that. But you just want to give them a little bit of value to them, and what you'll get is a more realistic behavior in your simulation overall, because stuff that's falling will have different rates at which they fall and the way they move around. So again, good rule of thumb is to use sizes mass, the mass operator when you're doing dynamics like SC on your particles, and make sure that you turn sizes mass on in the operator. You turn it on in your SC solver, or if you're using Bullet, you can turn it on in Bullet as well. And then, you know, it's a good idea to set up an air friction rule like this, which just says basically small, medium, and large objects get a little bit of friction, a little bit more as they're larger than the other particles. And that way, when they're airborne, moving around, they'll have just a little bit more drag than, you know, they would if they didn't have that. And the combination of that and the sizes mass during the dynamics, you're going to get a realistic looking simulation going on. So hopefully you find this helpful and you can use it next time in your setups. Thanks for watching.